Okay, welcome back, everyone. Today's presentation is called Elemental Constitution of Soul and Substance. So I really wanted to dive into the periodic table and to the various types of substances on there, to the metals, and also look at things like salt and sugar, as well as the human soul, and look at all of that and how it can be thought of in terms of the four elements or the elemental constitution. So the basic idea that I'm putting to the test here is that the ether theory and the atom theory are these kind of opposite, kind of contradictory ideas. And we've been taught to think of everything in terms of atoms, but actually there's a much older way of looking at things in terms of ether and elements, which I believe is superior and gives us a better understanding and a more practical and personal relationship with science. So ether is alchemical and qualitative. It's also spiritual in the sense that it's a spiritual substance. It's so fine that it penetrates all things. So the idea is that space is filled with this omnipresent fluid substance, and that matter is actually infinitely divisible. It's like a fractal. And all the substances are different forms of the ether containing these qualities of fire, earth, air, and water. Now, in the atomic view, this is scientific. It's quantitative, so it's all about the numbers of atoms and the number of particles in the atoms and so on. And it's material, so it's all about matter. In this view, space is an empty void populated with infinitesimal particles, and matter is ultimately indivisible. So when you cut it down and divide it into again and again and again, you'll eventually get to the smallest piece, which is the atom, and then that piece will not be able to be divided anymore. So in this view, all substances are different forms of atoms containing different numbers of protons. It's the number of protons in the nucleus that distinguishes one substance from another. And in this view, the fundamental elements are hydrogen, helium, lithium, and beryllium, and so on, the first elements of the periodic table. Now, I think Drake memes are a bit passé now, but I threw one in anyway. The periodic table of the elements is not the elemental paradigm that we have in alchemy. In this view, the word element has been changed. The definition of the word element was changed in the 17th century, and they changed it to mean purified substances consisting of only one type of atom. Okay, so before that, it meant a rudimentary substance, such as earth, air, fire, and water. But now it's like a special purified substance consisting of only one type of atom. So it's a whole different definition. Now, there's problems with it, which we'll get to on the next slide, but it's not periodic, doesn't contain the alchemical elements, and consists largely of man-made substances. So in fact, anything ending in ium, which is actually quite a lot of the table, is a man-made substance. And many of the entries on the table don't even exist. The atomic masses are assigned, not measured, and it's been grossly manipulated from its original form, its original concept. Now, with the elements, we have fire, earth, air, and water, and these are fundamental principles that embody the essential qualities of creation. They're states of being, states of matter, and stages of transformation, and the basis of all material and spiritual existence. Now, when we look at this, we see lots of things on there. I used to love this table. I had one on my wall when I was at high school and stuff. But looking at it now, with everything I've learned, I can see lots of problems with it, and I can break it up in a way that is more understandable in alchemical terms. So let's just, once again, just look at some of the problems here. Periodic table of problems. Not periodic. So it doesn't go around in a period, right? So like 8 rows, if it was 8 by 8, it would be periodic, like an octave. But it's not. There's 2 on the top, and then, yeah, there's 8 after that, and another 8, and then it goes up again and up again. So it's not actually a periodic table. Doesn't contain any true elements. And the chemicals are not elements by definition. So this has been, again, this is a definition that's been changed to make elements associated with chemicals, but chemicals are not elements. There's also this issue of the 3-body problem. So In physics, there's something called the three-body problem, and it's applied particularly to atoms and molecules and nuclei. And the idea is that when you get more than three particles interacting, the maths gets so complicated that there's just too many variables and you can't solve the problem. So this happens very quickly in the periodic table because you've got hydrogen, which is like 1 proton, 1 neutron, and then you have helium, which is 2 and 2, and then you have lithium, which is 3. But how the hell do you go from helium to lithium with just the addition of a proton? It's a very strange thing because helium's like an invisible gas with an upward vector. And the idea is that if you add protons into that, it will somehow turn into lithium, which is this obviously highly reactive metal that's made from rocks. So that's a three-body problem in and of itself. How does that even happen? It doesn't make any sense. So the substances have been basically reduced to a proton count. It's just like every substance just being given a number, 1, 2, 3, 4, and they've been simplified in that way. It hides transmutation behind a veil of atomic theory. So I'll get to this in a bit. So transmutation is real, is possible, but we're told by modern science that it's not. And we're shown this table and told that all the substances are different kinds of atoms and you can't transmute one into another. Now, as we said, the atomic numbers are assigned and not measured. There's over 40 elements in the table that don't even exist. So they've just been essentially flashes of light that were observed in cyclotrons that were claimed to be evidence of a new atom. So they do some experiment, they get this flash of light or this like dot on the graph, and they say, we found it, we found a new atom, and they give it a name and they put it on the table. But the problem is it's never actually existed as a substance. They haven't discovered a substance, they've discovered a flash of light, a moment in time, like an energy flash, essentially, and they've declared that to be a substance. So essentially everything beyond bismuth on the table is non-enduring or non-existing. And you might be thinking about things like radium. And I'm not saying radium doesn't exist. Obviously, I've not seen it, but there's a lot to suggest that it does exist. But it's non-enduring. So it's only radium when it's glowing. So when it's not glowing, what is it? Probably something a lot like lead. And then, of course, the table has been butchered from its original concept. I'll show that now. So this is the original periodic table by Mendeleev. And you can see it's got 8 columns there, and it goes around 8 each time. So there's a periodicity to it. So he was right to call it a periodic table in the beginning. It only became non-periodic later after he died and it was tampered with. But what's interesting about this is when you go to the top of the page there in the top left, the 00, that word there is actually newtonium. So I was told that he put the ether on his original table. And so when I looked at this, I was expecting to find the word ether. And so I went to a Russian translation and typed in the letters, and I was surprised what came out was newtonium. And it's newtonium because this was a name that Mendeleev gave to the ether in honor of Isaac Newton. So I know I can be very critical of Isaac Newton, but one thing he did believe in was the ether. In fact, he said in his letters and manuscripts, he spoke of a subtle spirit that pervades all bodies, a vivifying principle that animates the world, and what the alchemists call the spiritus mundi. He even speculated that this ether might be the sensorium of God, the medium through which the divine perceives and acts upon creation. Okay, so Newton was not a denier of the ether, and this is why he honored that in the naming of it. But then a few years later, shortly before he died, he published another version of the table, and as you can see, the 00 element has gone. The ether was removed from the table. Now, there was a campaign to remove the ether from science. And one of the big experiments that did this was the Michelson-Morley experiment. Now, I'm not going to go deep into like how the whole experiment works here, but I thought I would just show this plaque, which is the Michelson-Morley experiment conducted at Western Reserve University in July 1887, provides the earliest direct evidence that would later support Albert Einstein's theory of relativity. Michelson, professor of physics, and Edward Morley, professor of chemistry, tested the prevailing scientific theory that light waves travel faster downwind and slower against an upwind as they travel through a substance once thought to permeate space called ether. Finding no difference in the velocity of light waves traveling in different directions with respect to Earth's motion around the sun, the experiment's result baffled a generation of scientists until Einstein solved the riddle by formulating a new understanding of time and space. In 1907, Michelson, the head of the physics department, became the first American scientist to earn the Nobel Prize. He did so in physics. So I just brought this up because this was really a big effort to remove the ether from science. What they actually showed with this experiment was that the Earth was stationary and that there's a small ether wind blowing around the stationary Earth. But they interpreted it completely the other way. They assumed that the Earth was moving, and they declared that there was no such thing as the ether. And basically then Einstein's relativity was the only thing to explain the results. So they chucked out ether and they propped up Einstein's relativity in one foul swoop. And Tom Cowan did a great presentation just a few days ago. I just watched it the day before yesterday. It's on Rumble, Medical Doctors for COVID Ethics. And he talks about this experiment. He goes into more depth with it. And he describes it as the day that science died. Because from this day onward, Einstein and the people of that ilk essentially declared that science was about making stuff up. Go forth and make stuff up. A lot of science since then has just been made up. It's not been based in experiments and facts. And yeah. And I also thought this was quite a funny one. So there was a mathematician called Emmy No Ether, who was there around about the same time. And Albert Einstein said she was the most important woman in the history of mathematics. So there you go. I'm not even sure it was a woman. This seems like a kind of a psyop, honestly. We're supposed to believe she made all these contributions to abstract algebra, which supported the chucking of the ether from science. As the material conception of the luminiferous ether was dismantled by the Michelson-Morley experiment and Einstein's relativity, element zero quietly vanished from the official tables. The ether was exiled from the kingdom of matter, stripped of its elemental dignity, reduced from a substance to a mere property of space. Newton described the ether not as a passive fluid, but as a condensable spirit, a primal substance that can be precipitated into tangible forms. The one thing manifesting through different degrees of density. Mendeleev, in placing newtonium at the head of his table, was attempting to quantify the unquantifiable, to give the quintessence a place among the elements. He sought to bridge the gap between the spiritual ether of Newton and the material elements of chemistry. Okay, so back to the periodic table then. So I've divvied it up in a way that makes sense to me and helps us to break it down into the alchemical elements. So let's start then with the metallized salts. So what they call the alkaline earth or the alkaline metals, lithium, beryllium, sodium, magnesium, and so on. So these are highly reactive, non-sovereign substances. So non-sovereign in the sense that they don't appear in nature and they can't really hold their own very well because they're so reactive that they just immediately react with water or air. And they're made through transmutation of rocks, essentially, through rock salts. You take a rock or take a substance and you reduce it to an ash, like a salt, and then through several stages of dissolution and coagulation, you can start to purify this through different stages until it becomes in metallic form. And I'll go more into this later. But that's how those are made. They don't exist in nature at all. So then if we look, okay, we've got the black boxes here with non-existing, non-enduring, like I explained earlier. So these are things that either were just flashes of light in a lab one day, if that even happened at all, or they're radiant metals which don't endure in their current state. They radiate for a while and then they stop radiating. So non-existing or non-enduring, pretty much everything after bismuth. Then we have the transition metals. Now, I'll go more into those in another slide as well, but these are basically hybrid blends or alloys of the 7 planetary metals: iron, copper, silver, gold, mercury, lead, and tin. And I'll go more into that as well as we go. Okay, so what I've called Earth there is basically boron and carbon. And then the fiery elements in there, we have things like antimony and phosphorus and sulfur, arsenic. These are all fiery substances that burn. Air, we have things like oxygen and nitrogen. The noble gases there as well. And then the halogens, which are liquid. So those are like different states of water, and I'll get to those soon as well. And then hydrogen up there in the top left, I put that as red because hydrogen is sometimes called fire in potential because it just bangs as soon as it comes in contact with fire. Okay, so that's how I start to break it down. Now, Paracelsus said every substance contains all 4 elements in varying proportions. So let's look at that. So starting with everyday substances like wood, metal, and glass. Now, it's worth remembering that the elements are not just substances, there are sets of qualities. This is a qualitative science. So earth has the qualities of form and solidity. Water has fluidity and cohesion. Air, volatility and transparency. And fire is the agent of transformation. So when we look at wood, like dried wood or dead wood, we know that wood burns and it leaves behind ash. So wood actually is just earth, fire, and air. It doesn't have any water in it. We talked about this before. Wood can't be melted, whereas metal can be melted because metal actually has water in its constitution. Wood is earth, fire, and air, but metal is earth, water, and air. And then glass is essentially frozen air because it's earth and air. It has the transparency. It looks virtually identical to air. It's completely transparent, but it has the solidity of earth. And it's also a liquid, a very viscous liquid when it's heated. So it has a tiny bit of water in its constitution as well that makes it liquid. So you see how we can start to think of these substances in terms of the qualities that they have and how they relate to the 4 elements. And that is just a more intuitive way of thinking about things than thinking about how many atoms are in a gram of the substance using Avogadro's number or whatever. So then there's also the elemental constitution of the soul. So the idea is that every human soul contains all 4 elements in varying proportions. The 12 signs of the zodiac hold specific elemental qualities, and then the planetary positions in our birth chart activate those elemental qualities within us. So in this chart, for example, there's a spread, there's I think 16 different chart points. And then you look at which ones are in fire signs, which ones are in earth signs, air and water, and so on. And then you work out the percentage of each. So in this case, this would be 46% fire, 12.5% earth, 25% air, and 16.5% water. And then from this, you can then start to deduce the qualities of that soul. So whether it's the needs and likes, things that soul needs they don't have, and things that they like, the things that they do have. And diet and health tendencies and all sorts of things can be derived just from these four numbers, like your personal elemental soul signature. And so this relates to the Humour theory and the fluid balance. Okay, so good to revisit this. So we've got the sanguine humour, cheerful, social, associated with the dominant humour of blood, which is the air element, and the spring season. So you see in this diagram here, you've got the seasons as we go around. So in the top right there, we got the Aries, Taurus, Gemini, and there's a man on the right side, a woman on the left side. You got the four seasons and the four humours and so on. So choleric, melancholic, phlegmatic. And I've been through this before, but I'll just go through it again. So the disease or illness, the type of disease we get corresponds with imbalance in these four humours. Excess blood is usually associated with fever, redness, headaches, swelling, whereas excess yellow bile is anger, irritability, bitterness, digestive problems. Excess black bile is depression, sadness, melancholy, and excess phlegm is lethargy, colds, and respiratory issues. So interestingly, the word melancholy literally means black bile. Melon is black, choly is bile. So you can see how when we have the constitution, we can look at somebody and start to deduce maybe what are the kind of symptoms that they might be bothered by, and how they can adjust their lifestyle to be more in balance elementally. Now, there's also like a physiognomy angle to this. So you don't just have to take someone's soul signature from their astrological chart. An experienced practitioner will be able to read the elemental constitution from someone's face. So the choleric face, it has this kind of angularity, this kind of like angular intensity. And whereas the sanguine face is airy and it has this sort of like lightness, is just like air has levity. The sanguine face has this kind of levity to it. It's like happy and kind, and it lifts us. And then the melancholic, this is earth, and it's got this very sort of stabilizing, almost like cubic look to it, with this kind of earthy solidity. And then the phlegmatic is watery, it's calm, it's more lower set, like kind of the eyelids are a bit heavier. There's this kind of watery calmness, indifference about it. And so these would be people who have a really dominant humor, but of course a lot of us will have a bit more of a balance, a mixture of all of these. So it can be, some people have the look, but others will have a mixture of them all. So the 7 planetary metals: gold is the sun, silver the moon, Mercury, copper is Venus, iron is Mars, tin is Jupiter, and lead is Saturn. Now, these are listed in order of most perfect to most base. So a base metal is really a metal that doesn't have the properties that you generally want from a metal. So it doesn't have that sort of shininess and conductivity and luster. And lead is considered to be the lowest, the base level metal. But within it holds the seed of gold. Gold is basically the goal of transformation. It's very similar to silver, but one of the main differences it has is color. It has that fiery color of the sun coming through in the gold, and that takes it from noble and pure into divine and perfect. Now, the transition metals are said to be hybrid blends of the planetary metals, or alchemical alloys. And when you look at the properties of these transition metals, you can start to deduce what they are made from, which of the other metals they're made from. So a good example is nickel, which is made mostly from iron, but with a little bit of silver and a little bit of gold. Now this is to, essentially, if you think of a nickel as like one of the lowest value coins in America, it's low value because it's mostly just iron, but they've added a little bit of silver to it to give it a silvery sheen, and a little bit of gold to make it incorruptible. You can see in this artwork on the right here, I've got the 4 elements: fire, water, air, and earth. And each of them have certain metallic qualities that they give to the metals. So with the fire, you have luster, color, and incorruptibility. With the water, you have fluidity, malleability, and conductivity. With earth, you have strength, opacity, and permanence. And with air, you have sonority, resonance, and lightness. So sonority is like how well the metal rings like a bell, you know, how good it is for like musical purposes. So chromium is basically iron and mercury. If you look at chromium, it looks just like mercury, but it's more solid. It's like solid mercury. Vanadium, iron, copper, and mercury. So vanadium produces like really beautiful hues and colors and stuff, and that's from the copper influence, the Venusian influence. Titanium is gold with the addition of lead. So that's interesting because lead is Saturn, and Saturn is Kronos, and Kronos is the king of the Titans. So that's why it's called titanium. Zinc and cadmium, these are like mercury and tin. Manganese is tin and iron, and bismuth is basically lead with copper and mercury. So you can go through different metals, and when you start to understand their properties, you can then see which of the planetary metals are included in its constitution. Now, what about the planetary metals themselves? We can estimate their constitution by basically assigning approximate percentages based on their alchemical behaviors. So I've done this kind of thing a few different times with the AI. This is just estimated proportions, but it helps us understand. Mercury, okay, it's the only liquid metal, so we know it's going to have a high proportion of water in its constitution. 80%. 80% water, 15% air, 3% fire, 2% earth, okay? So mercury doesn't have much form and solidity, right? So really low earth, whereas it has a high fluidity and wateriness. Silver, the best conductor of them all, has 60% water, 25% earth, 10% air, 5% fire. Copper, 50% water, 30% air, 15% fire, 5% earth. So copper has that nice kind of balance there. It's not quite as conductive as silver, but it has a lot of other properties like ductility and malleability. Gold is said to be the perfect metal and have the perfect balance. So we have here like 40% fire, 30% air, 20% earth, and 10% water. That's 4, 3, 2, 1. Tin, 45% air. So tin's quite airy. It has a lot of sonority. It's useful for like bells and music and stuff. It's also lightweight. 30% fire, water, 15%, 10% earth. And then iron, 50% fire, 30% earth, 15% air, 5% water. And then lead, the base metal, 60% earth, 25% water, 10% air, and 5% fire. And that 5% fire is like the seed of gold, if you like. Yeah, so that's how, you know, so with transmuting the lead into gold, you would be bringing that out and exalting it. And yes, so remember, these proportions are not literal weights of substances, but they are qualitative. Now, with the halogens, this gets into the constitution of water. So fluorine was known as the dragon's breath. It's corrosive and devouring. And it's essentially like lightning in water. It's this unstable, destructive force. Chlorine, the bleaching spirit, is like the sea's wrath, as it comes from sea salt. It's purifying, but also poisonous. It's like cleansing, but deadly. And then bromine, known as the stagnant fume, is this kind of heavy, melancholic, basically like marsh gas. It's a very suffocating gas. And then we have iodine, the violet wisdom, which is medicinal and sublime, called the tincture of the stars. It's healing and volatile. So these are said to be different states of water's purification and corruption. They all come from water, essentially. They've been called water's fiery children. So fluorine or fluorite is hell's stone, found in geothermal vents and volcanoes, very much associated with fire and water. Chlorine, spiritus salis, or the spirit of salt. And then bromine, aqua mortis, water of death, found in stagnant swamps. So there's your earth correspondence. And then iodine, celestial tincture, violet medicinal, from seaweed. So there's a water correspondence. So what we have here are like the elements of the water. So we have fluorine is the fire in the water. Chlorine is the air in the water. Bromine is the earth in the water. And iodine is the water in the water. Okay, now just a bit about phlogiston theory, which gets into the constitution of the air. Now, we're taught about phlogiston theory briefly in modern education, but they tell us it's just this old theory that is outdated and nobody ever uses it anymore. But actually, phlogiston's not really a theory as such. It's a wise understanding of the constitution of the air. So it comes from the Greek word phlox, meaning fire, like burned up. So phlogisticated air is inflammable air. So burnt up or spent air that cannot be used for breathing or combustion. So what we'd call CO2. And then dephlogisticated air is flammable air. So this is fresh or breathable air that can be used for breathing and combustion, what we call oxygen. And then there's nitrogen, which is the sort of inert medium. It's basically dilutes the oxygen and carries the CO2 around. So yeah, nitrogen is like the medium that holds the oxygen and the CO2. Now, oxygen is an atomic theoretical name for fresh, breathable air. The name was invented by Antoine Lavoisier, and it's actually a misnomer because it meant acid forming. Oxy meant acid, generating or forming, so acid forming. But actually, oxygen does not form acid. It was mistakenly named that way, but we kept it. So now we always talk about oxygen, but it's not really an appropriate name for what we are referring to. So oxygen is flammable and combustible, which tells us that it carries the fire element in its constitution. Before it was called oxygen, it was also known as vital air or fire air and pneuma or breath. It corresponds with consciousness. So the amount of oxygen we breathe in corresponds with our consciousness. If we reduce the oxygen, we start to lose consciousness. The fiery principle is transferred from the air to the body upon inhalation. So this is really what phlogiston theory is teaching us. It's not telling you that, oh, there's this particle called a phlogiston flowing around in the air. That's not what it's telling us. It's telling us that part of the air contains the fiery principle, and when we breathe in, that fiery principle is transferred from the air to us and gives us the fire of life. And then when we exhale, the earth principle comes out in the exhale, which is the carbon in carbon dioxide. So using this kind of terminology, we can see that CO2 is earth air, carbon and oxygen. O2 is fire air, so it's air with the fiery principle in it. And then nitrogen is water air, because nitrogen is basically diluting the oxygen. And this sort of threefold split, I couldn't help thinking that's going to be the tria prima, and it is. So you've got your O2 is the sulfur principle, because it's got the fire in it. The nitrogen is the mercury principle, because it's watery, it's a medium, a mediating influence. And then the CO2 is the salt principle, because it's actually got the earth element in the air. Okay, so I was talking about mineral exaltation. So how we can start with some ash or a salt, and through a sequence of purifying operations, you can turn it into a crystal, or you can turn it into a metal. These are essentially different states of virtue, of mineral exaltation. So you have salt, which is the body, and this is fixed, corporeal, powdered, and earthy. It was known as caput mortem, or the dead head. You have to apply lots of fire. You have to burn it, basically destroy it, burn away everything that can be burnt away until all you have left is the essential salt, the unburnt part of the substance. The dead head, or the caput mortem. So then we have crystal, which would be the next stage of virtue. So crystal corresponds with spirit. It's ordered, it's geometric, and it's structured by celestial light. So it's mercurial. Crystals reflect light, and they take on structured form, which is said to be the receptivity to celestial influence. Then metal corresponds with the soul. So metal is perfected material. It's igneous, it's sulfurous, and is infused with celestial virtue. Now, the materials are reduced to salt by calcination, and then exalted through repeated cycles of dissolution and coagulation, which is where the saying solve et coagula comes from. Each cycle increases the celestial virtue of the substance, and the experiments can be timed with astrological alignments in order to infuse specific virtues into the substance. Now, I just want to talk a bit about potassium and bananas. So I'm just going to say it. Bananas don't contain potassium, but potassium can be made by transmutation of bananas. So you can take bananas and you can transmute bananas into potassium. But your body doesn't transmute bananas into potassium. And I'll explain why I really don't think it does. Right? Because I think that's what we're being led to believe, is that the body somehow turns the banana into potassium or extracts potassium from the banana or something, but I don't even think that's happening. Now, potassium comes from potash, the white ash left in a pot after burning wood. You can actually make potassium from the calcined ashes of any plant material. It's like you can make it from wood, fruit, leaves, anything, any organic material. If it is burnt and reduced to ashes, you can make potassium from those ashes. So the idea that you need to get potassium from bananas is a bit daft. You can make potassium from any organic material or ash. And you'll actually get more potassium from the peels than the flesh. So if you were eating for the potassium, it would make more sense to eat the banana peel than it would to eat the flesh. So what about the constitution of a banana then? We're told it's got vitamins and potassium and sugar and stuff. Bananas possess solar and lunar virtues. They're yellow like the morning sun, which is nourishing, sustaining, and life-giving. And they're shaped like the crescent moon, which is cooling, moisturizing, calming, and sweet. Banana trees have a Jovian virtues of generosity, abundance, and benevolence. Bunches of fruit are hands, like a bunch of bananas called a hand, and it's offered by the tree at a height which is accessible to humans. And the individual fruits are called fingers of the tree and fit perfectly in the human hand. Bananas are also thrice great, 3 times great. They are structured as 3 longitudinal segments down the middle. They consist of 3 parts, the fruit, the peel, and the seed. And they contain the 3 primes. They have a body, soul, and spirit. Okay, so the salt of the banana would be its body. The oils, the kind of flavor profile, would be the soul. And then the spirit, of course, is the life force, the vivifying spirit, or the alcohol. This is how to think of a banana in terms of it's a gift of nature that has all these virtues of the heavenly bodies, and we eat it in order to get those virtues ourselves. We don't eat them for the potassium or the vitamins. Saying bananas are a good source of potassium is like saying books are a good source of diamonds. Do you get this? Because you can take a book, you can burn it to carbon, and then you can take that carbon and put high temperature heat onto it and put it under lots of pressure, and you can make it into a diamond. But you wouldn't say books are a good source of diamonds, because you don't go to books to make diamonds. You go to books for the words written in the book. It's the soul and spirit of the book is what you want from it. You don't just want the material to transmute into its ultimate form. And then some people say fruit is just sugar and water. And this is very reductionist. I would say there's actually no sugar in fruit. And that may be a very controversial opinion, but when you understand just like how sugar is made, even though it can be made from fruit, there's no sugar in the fruit, because sugar is something else entirely that's been made through transmutation, very destructive processes to create sugar. Fruit has a natural living sweetness. It has wholeness and virtue and a body, soul, and spirit. Sugar is the crystallized caput mortem of the cane plant. Okay, so remember, the caput mortem is the dead head of the plant. Sugar is essentially that, but it's been crystallized. So it's got water in it as well. It's a compound without an individual soul or an animating spirit. And it's a drug, actually, that's 6 degrees of separation from the living plant. So there's actually 6 destructive processes of separation that it has to go through in order to get the sugar from sugarcane. So I had to show this video. It's very enlightening. So we have 1200 degree iron ball, and it's sitting on some salt there, and then put it on sugar and see what happens. All right, so sugar ignites, produces fire, produces steam, and it produces a thick, black, sticky substance. And this is because sugar contains earth, which is carbon, and water, and air. Salt is pure earth, so it doesn't react to the fire at all. So if we can think of that like our digestion, so our digestion is fire. So when we put these things in our digestive process, the salt is going to make it through the digestive fire unaffected. The salt is not going to be transformed by the fire. Okay, salt is pure earth. It's the principle of fixation, resists the digestive fire. Salt preserves flesh, gives it structure, and prevents putrefaction. I know living flesh and dead flesh are different, but preserving flesh, isn't that the whole point of health? The whole goal of health is to preserve your flesh, right? Salt does do that and prevents putrefaction, gives like form and structure to flesh. It enhances the flavor of food, but it doesn't tempt us to excess. But too much salt leads to fixation, right? Hardening of the arteries, like stiffness, stagnancy, right? That's the problem of too much salt, right? Because that is what its principle is, the principle of fixation. Now, sugar is earth and water and fire air, right? So sugars are called carbohydrates, which is carbon, hydrogen, oxygen. So earth, water, and air. But remember I said oxygen isn't just air. Oxygen is fire air. It's air that's infused with the fiery principle. And that's why the sugar ignites when exposed to the heat. You also saw the steam coming off. So all the lighter components of water came off as steam, but the heavier components of water stayed behind as this kind of sticky residue and then mixes with the carbon. So that's how you end up with this black tar-like gloopy substance, this carbon mixed with the lower components of water. The higher components have disappeared off in steam, and the fire has been ignited. So sugar inflames and congests. It also deceives. Sugar is a deceptive spirit. It can make bad food taste good. It can cause us to eat things that we ordinarily would not eat. It induces craving and addiction. And though it enhances the sweetness of things, it does tempt us to excess. There's a gluttony component, and desire and temptation and all this kind of stuff comes in with sugar. It is a drug. Obviously, too much of it leads to congestion, bloating, weight gain, inflammation, mucus, etc. And then, almost done, we talked a bit about supplements the last few weeks, and this is just an overview. I did some digging with the AI, and my Hermes AI called the supplement industry an alchemical tragedy. The supplement industry, a realm where the caput mortem is sold as the elixir of life. Okay, so they're basically selling you dead salts and telling you that they're like the elixir of life. They're gonna give you longevity or good health or whatever. It thrives on chronic reductionism. So it reduces health to a list of chemicals and protocols, reduces the human being to a machine, and reduces nature to basically a warehouse of powders. Now, the alchemical approach, minerals are never taken in isolation, but in spagyric preparations. So what this does is reanimates the caput mortem by combining it with soul and spirit. Now, this might be something like even just putting it in a tincture. So a tincture is spirit. So it gives it some animation, gives it some life again, rather than just taking the dead head by itself. It's like you mix it back with the oil and the spirit together. And this contains the whole plant. It's been separated and reconstituted into a more potent form. And fermentation is the process of infusing the dead head with new spirit. And that's why fermented food is better for you. It's got more life in it. It's medicinal. And I'm just going to finish with this one little video I just filmed earlier. It's just a funny thing. I went and typed in Einstein's laboratory into a search engine today and had a look. And is there anything here that looks like serious science to you at all? It's just all kiddie, cartoony, silly stuff. Just complete nonsense. So then I went and typed in Alchemist's laboratory. And you see all these like wonderful drawings and images of real laboratories, real scientific equipment. I think there's no doubt in my mind anyway. Einstein definitely seems to have marked the beginning of the end of true science. Anyway, that's all for now, folks. Thank you very much.